Now let's summarize the idealized scientific method we have been discussing. We start by making many observations under various circumstances. Recall that observation statements are isolated descriptions of what we observed at a particular time and place.
Based on these observations, we then come up with a hypothesis by making generalizations through induction or suggesting an explanation for the observations through abduction.
But general hypotheses are difficult to test, so we work out predictions from them using deduction.
Next, we conduct experimental tests and compare the results with these predictions.
If they agree, then our original hypothesis has been confirmed. If they disagree, our hypothesis may have been falsified.
Do all scientists follow the scientific method?
What we have discussed is an idealized description of the scientific method. In real-world applications, these steps may be arranged in different ways. However, it is essential to ensure that all steps are present to uphold the spirit of the scientific method. To demonstrate the importance of the scientific method in upholding credibility, let's look at an example from cosmology.
What is cosmology?
Cosmology is the study of the universe as a whole. Some typical topics studied in cosmology include the shape of the universe, what the universe looked like in the past, and what it will look like in the future.
I see.
This example is about another famous physicist, Steven Weinberg. He won the Nobel Prize in Physics in 1979.
I've heard of him. He was a very renowned theorist in particle physics and cosmology who not only pursued scientific research but also wrote various popular science books. One of them is The First 3 Minutes, which discusses the condition of the early universe less technically.
Exactly. I would like to introduce a quote from Chapter 1 of The First 3 Minutes, which I found very interesting. I remember that in the 1950s, the study of the early universe was widely regarded as not the sort of thing to which a respectable scientist would devote his time.
That's interesting. Although cosmology is an established scientific field nowadays, it seems respectable scientists would stay away from it in the 1950s. What did Weinberg think of this?
Weinberg seems to agree with this negative judgment because he wrote in the next sentence, "Nor was this judgment unreasonable." He elaborates further on this. Throughout most of the history of modern physics and astronomy, there simply has not existed an adequate observational and theoretical foundation on which to build a history of the early universe.
Why did cosmology have such a negative impression back then?
This is where the scientific method comes in. Different cosmologists propose various hypotheses which give different predictions, but with the technology at the time, it was difficult for cosmologists to conduct experimental tests accurate enough to show which theories were not in line with the tests. This made it difficult to distinguish various theories and falsify them.
So it must have been quite easy for cosmologists to construct theories as they were not easily disproved.
Indeed. The lack of effective ways to sort through these theories means progress in this field was very slow. Therefore, cosmology was not thought of as the best use of one's time in those days. Of course, in recent years, the situation for cosmology has changed drastically owing to the advancement in technology. We can now make precise measurements about the early universe.
Yes. For example, we can measure the cosmic microwave background radiation to an accuracy level of 1 part in 100,000. Better theoretical predictions have also become available with the use of powerful computer simulations.
Hence, we can now make very stringent comparisons between experimental test results and predictions from cosmological theories, allowing us to falsify more theories and propel the field forward.
This example helps to show how the scientific method has been applied to assess a whole field of scientific research. It is also a good example of how technological advancements have assisted the progress of scientific research.